Okay, let me just share my screen. And if you can give me a thumbs up, we have yeah? Okay, cool. Thank you. Well, thanks for having me. I'll do a quick intro of myself. I think we see each other every week, but if you've missed maybe the first two talks, I never introduced myself. And I think the idea today is to talk. We're in this talk series, we've been trying to do balance academic practitioner type talks. And today I want to wear mostly my other hat, which is as a consultant. So I'll be talking less about academic stuff, but as you'll see, it's hard to disentangle those two facets of my work. And what I want to talk about today is incorporating water quality testing in national scale household surveys and how that is helping address a data equity gap. So a lot of low resource contexts or countries in that, for that matter, that's sort of the scale we're talking about today. If you don't have the data, you might not be able to allocate resource properly. So not even having access to data could be one of the first impediments to having access to safely managed water services. So this is work I do as a consultant, part of the JMP, which is the Joint Monitoring Program, and that's joint between WHO and UNICEF. So that's what I do sort of in my spare time. But a little bit about me. I have a civil engineering degree. I studied in Brazil and did a little bit of my studies in the US, came back to Brazil. My grad school was at the University of Surrey, and that's where I started getting the first taste of WASH through different projects and opportunities that came about. That brought me to Canada to not work in WASH. I worked for a little bit at Health Canada, and then sort of decided to go back into academia, and so became a lecturer at the University of Glasgow, continuing sort of the balance between research, working with WASH, and then had an opportunity at Université Laval in Quebec. And since 2017, I've been based at the University of Victoria. So those are sort of the red stars are where I worked, the yellow stars are where I studied, and the blue stars are now sort of where we do work. Obviously, our group does work in Canada as well. So there should be a lot of blue stars in Canada, but I just wanted to depict the countries. And this is not done alone. So this is done in partnership. So either these are research projects or consultancies. And so really it's a mishmash of a lot of different experiences, which I want to talk about and share one aspect of these, which as a consultant for the Joint Monitoring Program. So also, a little shameless plug. As a part of this talk, I'm also the director of the WASH Canada NSERC Create. So this is what brings us these talks. And I'm just mentioning this now because come December, we're going to have a new round of recruitment. So there will be scholarships available. And I'll leave my shameless plug to that. So how did I get into all of this? Well, I'm a failed doctor in the sense of I always wanted to study medicine. And in Brazil, medicine, you do, it's a first degree. And I never had the marks to pass the university exam. And then for a variety of different reasons, I chose civil engineering. And only later in my 5th year of civil engineering, I came across, we're also involved with water quality, with infrastructure, and there's benefits to health. And that sort of satiated my need to work in some public health or health-related profession. So this is a photo I have of the first, one of the first jobs I had. I think it was working with Oxfam after an earthquake, and this was outside a health clinic. And so I think it speaks to the importance of water and sanitation, not just for health, but, happiness, well-being, safety. It's a basic human right. And I think that's where I kind of found myself in this balance, being very fulfilled with what I do, and is also why I like to research in this area. And I like quotes, and I think this is a very cool one in terms of the applied nature of research, right? It allows us to know things, but I think also maybe from an engineering perspective, it allows us to do things. And what I want to talk about today is sort of generating data, right? And so part of that is this idea that, if we can't measure a problem, how are we going to even solve it? So there's a quote, a management quote by Peter Drucker, and I've been told there's other versions of this that are the original, but I'm going with this. But it's, if you can't measure it, you can't manage it, right? So I'm going to, I hope no one cringes at the mention of MDG. We're going to go a little bit back in time, and then that's just to set a bit of the context of where we are with monitoring for SDG 6.1. So when we finished in 2015, our post-MDG era, we had the assessments were that by and large, most of the MDGs were met, and over 75% of the countries had coverage with at least basic drinking water services. So let's look into a little bit what that basic drinking water service means. So the MDGs, if you remember, was to half the population without access to safe drinking water. And that objective was reportedly met. But when we look into how this was measured, what was considered was access to safe drinking water. So through a variety of sources, the way that was determined was whether populations had access to either an improved drinking water source, and there's a list there, a household connection, boreholes, rainwater, etc., or it was unimproved. In other words, people are using vendors or unprotected springs, surface water, etc. And one of the main issues here is this is measuring access to, whether this is the right term or not, to a technology, right? Either you have access or not. But there's a lot of unanswered questions with this, right? So the issue is, well, that doesn't tell us what the quality was. Sure, there's an argument to be made that if it's improved, likely the quality is better, but that's still not proof. Was it accessible? So how far was it to get to it? And when you get to it, is water even available? So those are the three metrics that weren't really answered in that. And to give you a glimpse of sort of how measurements and observations are important, I have a question for the audience today. Is who washes their hands after the toilet? Now, I can't see everyone, and not all the cameras are there, but I'm going to have a hunch that most people are mentally raising their hands right now. And if you aren't, we'll okay. Some people are lazy, but raising their hands, but that's probably what everyone is answering, right? Now let's look at the difference between asking a question and observing, making measurements, finding data. So I still don't know the origins of this, and I've been using this slide for quite a while now, but this is related to washing hands and the difference between self-reported information and observation. So this is data from a rest stop in the UK. So this is a roadside stop, and people were asked leaving the toilet, do you wash your hands after using the toilet? 99% of respondents said yes, and 1% said no. Now, when we look at the observations, that tells a very different story. So, and this is also tells us a lot about maybe some gendered behaviors, but the percentage of men and women who actually wash their hands is only 30% for men and about 60% for women. Granted, people go to the bathroom to do other stuff, But that's shockingly low compared to the 99% that was reported. So that sort of gives you a glimpse of how we collect data matters, right? Now, let's go back to our topic of drinking water. And this is data from Bangladesh. So when we looked at just improved sources of water, 98% of Bangladesh had improved source of water. Now, when we start incorporating some water quality parameters like arsenic, so we could have a 50 ppb limit, or we could be a little bit more stringent and go down to the 10 ppb limit. We could ask, is water on premise? And we notice that the percentage keeps going down. Then when we factor in E. coli, so fecal contamination, now that's water that's free from that, it falls to 58. And when we do sort of the Venn diagram where everywhere meets, we find that only 53% of water sources were improved, free from contamination, and on premise. So that goes from almost 100% to almost 50%, right? So that's also a stark difference, and that's because we changed the way we monitor. So jumping forward and way forward, because we're 3 years from the year 2030. So we need to start thinking about the next thing, but our targets are universal and equitable access to safe and affordable drinking water. So the metric is measuring the proportion of the population using safely managed drinking water sources. So what is that? Well, it's an improved drinking water source that is on premise, available when needed, and free from fecal and priority chemical contamination. So those 3 criteria of accessibility, availability, and quality. So that means the safely managed service is where those 3 criterions meet, right? And to give an idea of how the MDGs shifted to the SDGs, so we had in the MDGs either unimproved or basic, and now this is where we are now. It's going up that service ladder towards safely managed drinking water services. So where we are in terms of data, so this is from 2019. Maybe this has changed a little bit with the last surveys that were done, but only 117 countries had national data on water quality, okay? So when you look there, it's not just, there's some big players there. We don't have, you would maybe expect Australia to be in there, China, Brazil. So there's a lot of big countries that don't have this data. Where does this data come from? Well, countries that have resources will have monitoring programs, and then we can use data from water providers or regulatory agencies to make these estimates of what the drinking water quality is, but those need to be made available. But other countries might not have these programs in place. And so where can we get this data from? And that's sort of the data equity gap that is being assessed, and one is being addressed. And one means of that is through household surveys. So one type of household survey is called the MIX, and it stands for Multiple Indicator Cluster Surveys. So these are surveys that were developed by UNICEF in the 1990s, and to address exactly these sort of data gaps, right? To fill in data gaps, mostly concentrated on women and children well-being, but there's a variety of other things that can be in there, and WASH is a key indicator of well-being as well. So there's other types of surveys. So MIX is just one of them. Household surveys, there's the LSMS, the Living Standards Measurement Study, the DHS program. So LSMS is the World Bank version. DHS is from USAID, and they have similar types of surveys. So MIX has been running since 1995, and that's over 22 years. I need to update this slide a little bit. We're over 109 countries. I think MIX is now in its 7th round. And last I checked, it was about close to 350 surveys. And so this is really able to address worldwide these data gaps. So in yellow, you see countries that have benefited from these types of surveys. And the main module is a household questionnaire. There's a questionnaire for individual women, questionnaire for individual men, questionnaire for children, age 5 to 17, and for children under 5. And in the household questionnaire is where a lot of wash-related questions are, but no measurements. And that's where the water quality questionnaire and the water quality module comes into play as an add-on to the household questionnaire. So this became a unique opportunity for us to collect this data through these national scale household surveys. And that allows us to measure those 3 indicators of quality, accessibility, and availability. So the type of source, the accessibility, and the availability, that's in the household module. And the water quality will perform a water quality test, which I'll talk about next, and that gives us that data. So together, we can, with those 3, we have good indicators for safely managed drinking water services. And so what we're measuring is priority contamination, which is typically only fecal contamination measured through E. coli testing. There are debates as to whether E. coli is the best indicator or not, but they do have its limitations, but it also has a lot of benefits of being a type of measure that could be relatively simply done, and that's what I want to show. So typically in these surveys, we'll collect 2 samples, one from the source and one from the household. So the household is your point of consumption, and we want to know what do people actually drink. And the data coming from the source, that test indicates us that's what we're going to use for the safely managed drinking water service. So typically our plates, we would like to see them completely clean, as we see on the left, or many times we might find they're heavily contaminated. So that's what we're measuring. We're measuring these colonies, and there's a technique that goes with that, which I'll go through here. So the idea is to collect those 2. I'm not going to go into point of use, post-collection contamination, but the idea is that after water is collected, there's a variety of risk factors that if they aren't avoided or eliminated, water can be contaminated before its consumption. So that's why we want those 2. And in the mixed water quality test module, we're going to quantify E. coli and translate that into risk levels using an adapted membrane filtration method. This test for trained measurers will take about 5 to 10 minutes to conduct the test, and that's followed by a 24-hour incubation period. And there's a variety of other quality assurance and quality control. So we do training, and that's what I'll speak about today. We do blank testing to make sure that there's no external contamination, and close field supervision of the teams. So in mix, we talk about clusters, and I'll show you, for example, what a cluster, that's not what a cluster looks like, but a cluster is essentially, think of it as a subset of a population that will give us a representative portrayal of the situation in that. So every country would be divided up into clusters. Typically in each cluster, 20 households are selected for the mix module, the whole thing. And of that, a subset of 5 of these are selected for the drinking water module. And of those 5, one of those houses are selected for a blank test for the quality control. So we're really doing a subset of the clusters. And to do that, we need to train teams of measurers. And that's my job as a consultant, is I do a lot of the training. So we help plan these surveys, everything from materials to logistics, and also delivering training. So a lot of these measurers are surveyors. They have different backgrounds ranging from maybe high school to an undergraduate degree, but in a variety of, they're not water quality experts. And by the end of 1 week, they need to be proficient in how to do these tests. So typically, this is what I chose a 4-day agenda because that fit nicely onto the slide. But these can go up to maybe 6-7 days of training, depending on the type of survey. So the idea is we have some in-class presentations and practices. We do a little bit of field work so that measurers can get the idea of how this is. It's almost like a dress rehearsal, a lot of discussions and preparation for the main survey. And I'll give you an overview of what that looks like. So this is water quality training we did in São Tomé and Príncipe. So these are our two ex-colonies of Portugal. So one of the languages, the official languages is Portuguese. And coming from Brazil, that became an asset to go and deliver this training there. So these are two small islands that form the country of São Tomé and Príncipe. And there we did part of the round 6 in 2019, the water quality module. So basically what we're looking at here is the water quality test kit. So every measurer will be given a test kit and they apply this together with the questionnaire. So the whole idea of this training is how to identify the right source, where to sample, and then once you've collected all that information and collected the samples, the measurers then proceed to do the water quality testing. So again, the idea is to transform or to make these measurers evolve from non-water quality experts to folks that are proficient in doing this by the end of the week. So that usually starts with day 1, focusing more on the technique. So everyone is having their first chance at doing the water quality test. And then by day 2, we're incorporating this technique and putting it together with this questionnaire. So here they're working in pairs, and usually it's sort of, we're doing role playing. One person takes the job of a measurer and the other one is playing the role of a household. So we give different situations and we're seeing if the questionnaire is answered accordingly to the situations we're trying to simulate. A lot of practicing, so how to sample, different water sources, different water quality, and how to interpret those samples as well. And so, as you can tell, very hands-on, a lot of practicing, both the technique, and then part of, for example, the quality assurance and quality control is we want to make sure everyone can interpret these samples in a standardized way. So for example, here I've selected 4 different plates, and I want to make sure that everyone can interpret these and record these in the same way, so that at least we can verify that we're achieving consistency. So by the end of that, I collect all the data and I can compile a report and have these sort of box and whisker plots to see where there's big deviations from where most people should be achieving relative to a standard. So that's standardization. And then in the last 2 days, typically we go and we practice in households. And this is where everything needs to come together. And they will be doing this in real world situations. So they'll face everything from very nice households like this lady who is graciously providing her time and water for us to test, to, for example, households that are resistant or very skeptical, and they need to put into practice their convincing and explaining what this is. So obviously this is all done through informed consent, but this is part of what a measurer needs to do, and this is what we practice. So here we see the measurer doing a test on the household steps. So we don't work in the comfort of a classroom anymore, and that's likely what they'll be doing in the field. And we see collection of samples to the left and to the right, and to the left, we're seeing a process sample being incubated. So that's a belt that this measurer will be wearing for 24 hours because the plates need 35 degrees Celsius to incubate, and that's using body temperature. So once they're doing their survey, they might be spending the next 2 to 3 months collecting household samples almost on a daily basis wearing these belts. So it's a lot of hard work and a ton of effort, and I have a lot of appreciation for what they do. and sort of the information they can provide. And I think in every survey I've worked so far, they understand the importance of this, and they're very proud of their work. And nothing shows that how proud they are is the way to test to see if they actually learned is the measurers get to train their supervisors. So here we have measurers and they're training their supervisors on all this technique. And this is when you can really see that everything has come together and they can even explain it. So it's job well done and ready for the survey. And then I have a few more slides just to show a few other surveys, how they work. So this is a survey done in 2017 in the Democratic People's Republic of Korea, otherwise known as North Korea. You know, a lot of practice going into collecting samples, processing them, different sorts of urban or peri-urban environments, different sources of water, so water coolers, tap water, water vendors, and again, all of this is practice-based. But what I really want to show is sort of an example of the data this can generate. So we can see, for example, we can divide national averages of safely managed drinking water services, compare that between urban or rural, and then that, for example, for decision makers, lets them know where they need to allocate more resources. We can compare between provinces and disaggregate this data into wealth groups and levels of education. So this data becomes, together with the household data that was collected, it becomes a very rich set of data for decision making. So going back to that, if we can measure it, we can now manage it, right? We get other indicators. So for example, time spent collecting water. So we can look at if it's under 30 minutes, between 30 minutes and an hour, between 1 to 3 hours, or over 3 hours. And we can also look at other inequity issues, such as who collects the water. And here we're seeing typical, what we see in a lot of countries, that's usually a job, the time burden lifted by women in particular. So again, once we have data, then we can target and make and understand not only what we could do or what benefits this would have. So here is an idea of the benefits in time from collecting water. And then this also indicates that graph similar to what I showed in Bangladesh. So before, if we just looked at improved, we would have 94% using improved water sources. But when we go to adding the other indicators, we get down to 63 are safely managed. So where we are right now is we are already in the mixed 7th round. So this slide needs to be updated a little bit. But we have a lot more countries. So this was just the pre-COVID slide, and I think we have another at least 60 more countries joining it. So really it's something that could be scaled up and generating much more data. And the most important thing is not just to generate it once, but to start generating it with a little bit more frequency, because then we can start making projections of how fast or slow or what sorts of speed we need of improvements in these countries. And other things that have resulted from this are variants. So there's different types of training, and maybe this is a very poorly selected map, but what you're looking at is arrows pointing at Fiji, and this is a different variant in the type of training. So rather than training the measurers themselves, this was a training of trainers. So this was an assignment where the Federated States of Micronesia, Nauru, Tuvalu, American Samoa, Tonga, and Fiji all met in Fiji, and we trained the trainers who then went back to their countries, and it was sort of like a trickling type of training mode. And I think most of the surveys have now been completed. So speaking to sort of how we can scale this up, and obviously during COVID, we did a lot of remote training, which was a challenge, but also showed to work as well. So here is just to give you an idea of the the number of countries and the clusters and the teams that these trainers went out to train in their respective countries. Other variants, I just came back from Panama. So now we're doing the same module and doing it in WASH in schools surveys. So rather than just collecting information of how many toilets between boys and girls, the state of them, et cetera, we also have an indicator for water quality. And we did this training, a pilot training a couple of weeks ago, and the first survey for Panama is gonna hopefully roll out next year in the spring. Part of the barrier in doing this is the cost of the equipment. So here are costs in Canadian dollars. So that's the equipment we use for these. It costs about $1,500 all in for the manifold, which is the most expensive part of this. There is a lower cost version, and that's using a glass beaker, and that costs about $150 US, and we've used this with relative success in some of our research. And I'm happy to share, with the blessing of Rick Johnston from WHO, the new version that might be coming out that's being prototyped, and I think it will come out to less than $2 each. So this is plastic molded and fits the funnel, and we can do the membrane filtration in the same way. So the idea is that, you know, this shouldn't be a hindrance is the cost anymore of the equipment. And there's other places where we can reduce these barriers from a technical perspective. And this is where my world as a practitioner and researcher start to get mixed. So we're looking at alternative incubation methods, so no longer the need for those belts. This might not be too practical in a mixed survey, but we have experience with off-grid incubators. So here what we're looking at is the ColiAlert test, and these are 2 bottles of water that are filled with water at 60 degrees Celsius. And we've seen that we could maintain an average temperature of about 35 for about 12 hours. And so if we just have access to heat, we can boil some water and keep these tests going. And down here is the version that we did in some of our field work here on Vancouver Island. So boiling water, filling these water bottles and these coolers, and we managed to incubate samples overnight. Other alternatives are, we're working with FairCap, and here we have Rachel taking these incubators to new heights. I think we were at maybe 2,800 meters in altitude in Colombia. And here's a little power bank, and her colonies were kept nice and warm and grew, and we could count colonies with these tests. So again, an alternative, and we're looking to validate these. Other research is going into reducing waste. So there's a lot of consumables that go into this. And so how do we reduce the waste? Where we're looking into funnel reuse, and there's a few other ideas that we're either working on now or we have worked. And so we have a few sample publications also for later. And I think that's all I had. So there's definitely a lot more to do on this topic. So there's a few resources that I would point everyone to, which is the Mix website, and it talks about sort of their surveys. You can access the surveys, the manuals we use for the training, everything is on that website. The next website that's there is washdata.org. So what happens to all this data? How do you make projections? So this is an open access platform, and you can access all these data. You have country files, and typically if the country file is complete, you'll have data on household water, sanitation, hygiene indicators. There might even be healthcare facilities, or maybe even WASH in schools. So really a very complete and rich data set to use. And these are 2 publications by the JMP. One is about the experience of using this water quality testing in 27 mixed surveys, and a PDF that sort of talks about integrating these water quality testing into household surveys. And with that, I will thank everyone for their attention, and I guess we go into questions now.